In this video, we're going to be comparing graphs of functions with their parent functions. So we're going to begin by comparing the graph of some square root functions. And here we have our parent function, f of x, which is the square root of x. That's going to be our parent function. So go ahead and that'll be our underline in green. All right, so we're going to begin by taking a look at what we have as far as our equation. So our first equation says g of x equals negative square root of x. Now we want to remember what exactly that means when we have a negative out in the front. So if we look at our our general formula equation here, we see that when we have a negative out in the front, that's going to be a reflection in the x-axis. Now it doesn't matter that this equation that we're seeing here is our square root, isn't a square root equation, it's a quadratic, it will still work because those rules are all the same. All right, so let's go back to our problem. So a reflection in the x-axis. So here we're expecting to see a reflection across the x-axis. That's what we're expecting to see. And so what we're going to do is we're going to go ahead and we are going to graph this using our graphing calculator. So we're going to go ahead and we're going to put in our square root of x. Remember, that's our parent function. And then our second function is going to be the negative square root of x. And so our blue graph will end up being our parent function, and the red graph here will be our new function, will be our g of x. So we'll hit graph, and there we see a parent function, and it's f of x. So we'll go ahead and we'll graph. Here is our f of x, right? That's our f of x, our parent function, and this was our g of x. Oops, make that a little bit better. So our g of x. And we see that indeed it has been reflected across the x-axis. So we already know what our parent function is going to look like on our graph. So we can graph that right now, right? There's our f of x. But what is our h of x going to look like? So here we have a negative on the inside. So what does that mean when we have a negative on the inside? Well, if we come and look at our formula, when we have a negative on the inside, that should be a reflection in the y-axis. So here we're expecting to see a reflection. Let's use a different color. We use blue this time. A reflection across the y-axis. So what we're expecting to see is we should see something like that. But let's check and make sure. So we're going to pull up our calculator, and we're going to go to our y equals, and our parent function, our f of x, is going to stay the same, but our second equation should be the square root of negative x. We'll graph that, and we see that we were right, that our graph is going to look like that. It'll be reflected across the y-axis. Let's look at our third equation, and this time we have a couple different things going on. Here we have a negative in the front, which we know from our first one is a reflection, reflect across the x-axis, but we also have this +2 inside. So what happens when we have a +2 on the inside? Let's take a look. So if we look over here, we see that if we have a plus, so something on the inside means that we're going to be moving left or right, and a plus means that we're going to be moving to the left. So we can go ahead and write that down. So we're also going to move left 2. So we know what our parent function should look like, so we can graph that already. That's not going to change. Our f of x is not going to change. F of x. So we'll go to our calculator, and we will plug in the second equation, negative, square root, my goodness. Let's try this again, negative square root of x plus 2, and we'll graph that. And we see that it's reflected across the x-axis and it's moved over 2 places. So we're going to take our base and we're going to move it over 2 places, and this is where it'll start. And then we have it reflect down. And that's going to be our k of x. Let's do a little bit more comparing. Let's try comparing when we have absolute value function. So here our parent function is going to be the absolute value of x. So remember, that should be a graph that kind of resembles a V. So here, remember, here's our parent function. So here's our parent function. We have a 3 out in the front. Well, what does that mean? Well, if we have a number out in the front, according to our graph, that means that's going to be a vertical stretch or shrink, depending on if it's a whole number or a fraction. So if it's a whole number that's greater than 1, it'll be a stretch. And if it's a number that is smaller than 1, that will be a shrink. So we'll come back over here. And we're going to go ahead and say that we're going to have a shrink. Nope, it's a whole number greater than 1. So we're going to have a vertical stretch by 3. Vertical stretch by 3. And this is something that we can plug into our calculator. So go to our y equals, and we'll clear both equations. And to get to the absolute value symbol, we'll hit math, arrow over to number, and hit ABS. That means absolute value of x. So there's our parent function. And for a second, our g of x will have 3 times the absolute value of x. And we'll graph those. Notice that by vertically stretching, by pulling it away from the x-axis, we're making it narrower. And that's what that's going to look like. And so if we were to sketch it, it would look something like that. So let's take a look at letter B. So we know that it's going to be a vertical because it's on the outside. But this time, our number is less than 1. So instead of being a stretch, it's going to be a shrink by a factor of 1/3. So think about what that just did to our last graph, right? So we know that our parent function looks like this. And if we know a stretch brought it closer to the y-axis or pulled it up from the x-axis and made it narrower, shrinking should end up bringing it closer to our x-axis, making it wider. So let's just check that and see. So we'll graph that. And so we'll go to our y equals. And instead of a 3, we're going to put 1/3. And we're going to graph it. And there we go. We see that it is wider. So a vertical shrink is actually going to be a wider graph. And a vertical stretch will be a narrow graph.